I got answer my
Mm-hmm.
hold on. I got 1/2024, and then I look at the key answer key, and it's 005, I believe, or something like that, or zero
Okay,
zero zero.
well, let's take a look.
I'm like, how?
Because this one I haven't checked, but I think it might just be changing it to a decimal.
Okay, how would I'm like? I was talking to my son that he's a little bit better with math, and I'm like, okay, how do I
Mhm.
change the decimal 1/2
Well,
thousand?
I will show you right now
Okay,
because your calculator will do that for you.
okay,
Funny how that is, but it will actually help you do that. So let me clear this out. Can you see? Let me make sure my calculator is actually showing on the screen because sometimes it doesn't. There we go. Okay, so you have, okay, let's make sure we're together here. This is 3 out of 24 times 2 out of 23 times 1 out of 21, right?
or
Enter.
20? Would it be 22? No.
Is it 22? Yeah, it
Yes.
is. Let me go back to that. Thank you for catching that error because that would have been, this is one of those ones where the decimal is super small, right? But
Mm-hmm.
what happens here is, I don't even know if it's gonna, let's see if it'll convert it. Math convert to frac. It might not. Let me see if it did. Yeah, it did. Now, some calculators won't do it when it's that small, but that's all I did was go math. So when
Okay,
I was here, so let me go back to this. Here's my answer, right?
gotcha.
And then go to math right here.
Mm-hmm.
And the first option on that menu is a little arrow with frac. That means convert to fraction.
Okay.
So hit number 1 or hit enter, and then hit enter one more time, and it should convert it for you.
Okay.
Most of the versions will do that. If you get an answer, and this is something that came up for some of the other students as well, if you get an answer that it doesn't convert, don't worry about it. She's not going to make you on the if you're doing it in class, especially, she's not going to make you go and manually do this by hand. But if your
Okay.
calculator will convert it to a fraction, you should.
Okay. So I basically go to mode um
No, math. It's not
math.
mode, it's math.
Okay.
So
Okay, that's right.
it's math. It's under the alpha key next to apps. So it's,
Okay.
let me spotlight it for you so it'll show up on the screen.
Okay,
So
but
it's
quick.
math here.
Okay, quick question. See how I have I just try to go decimal because I
Uh-huh.
know she has the answer with the decimal,
Mm-hmm.
and it came back with the 4.9071, and
Mm-hmm.
her answer on the key was um
Point
point.
zero 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 five, right?
Yes.
Okay, look carefully at this. This is something that happens. Um, Let me show you here. Second
Okay.
entry. Okay, now this is, let me get rid of just this part. Let me see if it'll delete that without deleting the, okay, so your answer was this ugly thing here, right?
Correct. Yes.
Now remember that a probability has to be between 0 and 1, right?
Okay.
And this looks like 4, so this looks impossible, but look at this right here. This E negative 4 here.
Okay.
This is scientific notation, okay? Which means this number is so small that your calculator is putting it inside. So what this means is that you actually have this answer. This is, and just for the sake of simplicity, I'm going to round this to 2 decimal. This is 4.94 times, now that E means this. It means times 10 to the negative fourth power. That's what scientific notation does. It makes it, now if it's a negative power like this one, it means that we're going to move this decimal point to the left. So we're going to move the decimal point that you see here
4 times.
left 4 places.
Okay.
And so keep in mind that that doesn't mean you put 4 zeros in front of this. It means you move this decimal 4 times.
Yeah.
So it actually means that you get this answer. You get 0.00049 and then so forth, right?
Correct.
Now, if you round this, I mean, there's more digits after. I'm just going to put dots,
Yeah.
okay? Now, if you want to round this to 4 places after the decimal, then this 4 here has a 9 behind it, right? So
Yeah.
when you round it, this is going to be 0.123 and 5.
Gotcha.
That's
Okay,
where
I
it's
was like,
coming.
I'm like, okay, now it makes complete sense. Um, you know what? Okay, what else did I
So
write?
that was the correct answer. Okay. It just didn't look
Okay,
correct, but it really was.
Okay. I was having even a hard time even coming out with the number 15.
15, sure.
Yeah.
Let's take a look at, do you need anything else on the screen or can I go ahead and?
No, no, I don't need that. I
All
kind of got
right.
it.
So let me get rid of that for now. And
Oh,
let's
you know,
go
quick
back.
question, Shauna.
Yes.
When I put, do I have to put 4.9407 and as an answer and then kind of like,
You could, but you could also just record this fraction and then convert this answer to a decimal.
Okay.
You want.
Gotcha.
Yeah. Okay.
Okay, gotcha.
Anything else about this?
No.
Okay. All right. Let's see what we've got here. 15, you said?
Correct.
Let's see. Let's take a look at 15. Oops, not the answer key. Let's take a look at the question. Okay, it is reported that 19.8% of computer games sold in 2005 were classified as family and children. Choose 5 purchased computer games at random. Find the probability that none of the 5 were family and children, or at least one of the 5 was family and children. Do you need help with both parts?
You know what? Maybe to start off with the first one. Let me see if I can kind of like.
Okay. So none of the 5 were family and children. What is going through your head with that?
So that's kind of like 80% was non-family and children games.
You're on the right track. So this percentage, okay, so that's a good start. This percentage here that you see given was family and children, right?
Correct.
What we want is what we call the complement of that, right? We want the ones that were not family and children, right? So what we're going to do is, now keep in mind your percentages have to add up to 100, right? So they either were or they weren't. So if you, this is actually going to come out to 80.2, right? So the first thing you want to notice, and you did, was that the probability that a single game is not family and children. And just to show some of the work for the sake of people watching this later, or if you decide to go back and watch it, I'll go ahead and show the step here. This is 1 minus, And I'm going to turn this 19.8 into a decimal. So 0.198. And if you subtract that, you get 0.802, right?
Correct.
Now, how many games are you choosing here?
5.
Right, you're choosing 5 of them. So here, we now want to take this probability of choosing 5 games that are not family or children. And again, we have to assume that they're independent picks. We don't have any information that would lead us to believe otherwise. It's not part of the same family. It's not anything like that. So all we're going to do is we're going to take our decimal 0.802 and we're going to raise it to the 5th power.
Hold on one second. Sorry about that.
Oh, that's fine. So we're going to take this 0.802 and raise it to the 5th power. Okay, because essentially we're going to multiply this percentage by itself 5 times.
Okay.
So we're going to go back to the calculator because the calculator is our friend.
Correct.
And we're going to say, and it really is, once you sort of understand how the calculator works and what it can do, it is your friend. But until you sort of learn what it can do, it becomes a little bit of your nemesis for a while. This is 0.802 raised to the 5th power. And there we go. It's 0.3318.
Oh wow, that was super simple. Okay.
Talk to me, Mauricio.
No.
Just ask
Honestly,
your question.
I said like no. It was super simple the way you, like with the calculator to the 5th power, and right away the answer comes out.
Yeah.
So,
I mean,
okay.
you could multiply it out 5 times, but there's no need to do that.
Yeah, exactly.
The
What for?
calculator will do that for you. There's the best way to enter it when you don't have a power like 2 or 3 is to use this symbol that's a triangle without the bottom, called a caret, C-A-R-E-T, and that just tells it that you want an exponent.
Okay.
And you just put in, you can use it for any exponent, but if you have a 2, you already have a key that gives you a square, but you can use this caret for any power that you want.
You know what? One question. I should have probably logged on with the professor, but I got those messages or emails saying that the quiz on Thursday, it starts at 1 p.m.
Mm-hmm.
Are you aware of that?
Okay, so are you in her in-person section or are you taking it online?
Online.
Okay, so the online section is she's gonna open it and it's gonna stay open for, I believe, 24 hours.
Oh,
but
okay.
I did see those emails. I think that was meant to go to her
Other class?
yeah, and I think it went to
Gotcha.
yeah, I had seen that and I was a little bit, I'm gonna text her right
Okay.
now. But I believe that's what's going on. Because as far as I know, there wasn't any change to that. So
Okay, that's what got me confused. I'm like, wait, is it time? I'm at 1 p.m. I'm like,
no,
okay.
but it's also but also be aware that I have extra tutoring hours Wednesday and Thursday, so you guys will be able to come back. Did you see that email with my
Oh yeah,
schedule?
no, I did see it. So that's why I'm like, okay, you know what? Let me log in a little bit on the problems that have questions on.
Yeah.
Like how do you got I know I get
You
the
guys
answer
are
right, but
actually, I don't know if you are, I mean, she's made you guys aware of it, but that doesn't necessarily mean that people are, but you're welcome to come in. Now, I can't solve the problems on the quiz, obviously, right? But I
Exactly.
can, if you bring in your quiz to a tutoring session, I can give you hints and let you know if you're on the right track or not.
Okay.
So if you, and she can do the same thing. Just be aware that anything that you do right and anything that I do help you on, you're going to have to understand well enough to be
At
able
the end
to
of the day, to
defend it.
explain how I got the answer.
Yeah, so just be aware of that. She's not gonna like drag everybody in to talk to everybody, but she will know if somebody is taking advantage of it. Unfortunately, we had some issues
Okay.
with that
No, no,
prior.
no
So.
problem. I understand. But I just like sometimes I get the right answer and I look at the answer key, but then I'm still like,
Yeah, no, and
I want
believe me, on these
clarification.
sections, that happens a lot. That's why there's, I don't know if you've seen it, but there's a lot more video support than there normally is, and there's been a lot
There
more
is,
tutoring
but you know
support.
what? Sometimes I get lazy to click on them because I'm like, okay, I have specific on this question,
Yeah.
and it's like, okay, let me see where I'm
Yeah,
going
no, that's
wrong.
fine too. And if you ever have, if you want to drop me an email, I can probably like, if it's in a video, I can probably timestamp it for you and be like, watch this, or I can even
Okay,
give you a response. I mean, you don't have to,
okay.
I just want people to have it because I
You
know
know what's funny?
people.
Because I think last week I was like, oh my God, I missed um the tutoring sessions at the time
Uh-huh,
slots. It's like,
uh-huh.
oh my God, I messed up. So I'm like, I'm trying to look through all the videos for
No,
my quiz.
it's fine. But like I said, if you're looking for something specific, don't strain yourself, just email me.
Gotcha. All right. Well, thank
Because
you so much.
I was there, so
Okay,
I was
no
there, so
problem.
I can probably go back to it and be like, okay, you want to watch this segment here, or I can, if you send me, what's the only thing that's a little hard is if somebody says, I'm having problems with number X, right, and they don't tell me
Mhm.
anything else. Now I'll help you, but if you don't tell me what kind of problem it was, or what you were having problems with, then I kind of have to do my best to explain. It's like explain everything,
Without giving you the answer. Yeah,
which may or may not answer your question if you had a question. You know what I mean?
exactly. Yeah.
So just be aware of that, because that does happen sometimes.
Okay, no problem. Well, thank you so much, Shauna, for answering,
Anything
helping me with
else?
the. No, no, that's all for now.
Okay,
Maybe I'll log in tomorrow again.
I will ask Professor Nickdell about that, about the
Okay.
whole quiz issue, and I'll have her email you. If I get an answer from her, I'll send you a message in the Canvas inbox.
Okay. Thank you so much, Shauna. Have
You're
a nice
welcome.
evening.
Take care,
All right. You
Mauricio.
too. All right. Bye.
Bye now.
Bye.
Let's see.
Not number one on 4.4.
Oh, 4.4. Okay.
Uh-huh.
Let me see if I think I have that chapter open. You're only my second student tonight.
Oh.
That's like, oh yeah, it's open. Yeah, there it is. Okay, so we're doing counting rules. All right.
Yeah.
So the first few of these are just counting rules. What's giving you problems with number one here?
I just wanted to know like how to approach the problem. Like, so for 5-digit zip codes, if digits could be repeated, would I put like, because I know in our examples we put like a table to see the events and the possibilities. So how would I do the same for number one? Because usually they gave us in the tables, they would give us two numbers, but this time we're working with one.
Well, okay, you have to think about think about in terms of, all right, so let me answer that question. Because the table is just actually designed to help you visually. Some people just use slots, like dashes. So it's up to you how you want to do it. But if you wanted to do this, you would say, like, here's your text box. So you might do something like choice and options, something like that, right? And so you'd have the first, so this is you're gonna have 5 numbers. So the first number, right? And then you're gonna have the second number.
Okay.
And you're gonna have the third number. The fourth number. And the fifth number. Fifth number. Okay. Now, as far as the options go, the only thing that's slightly tricky about this every semester is, and it seems like a simple question, and it is, it's not a trick, but how many digits are there?
There are 5 digits.
There are 5 digits in the zip code, yes, but how many digits can you choose from?
I don't know.
Well, think about a zip code. What digits can you use for a zip code?
I could use 9. I could use like numbers 0 through 9.
0, okay, all right, that's what I needed. Now, the question that I was asking you is how many digits is that? 0 through 9, how many options is that? In
10?
other words, yeah, that's 10 digits. The reason I bring that up is that a lot of students think it's 9 digits because they forget about 0. And that's a big deal. There are 10 digits. This is 10 digits, okay? Digits, by the way, when you see this, because this comes up in other problems too, so you probably cleared this up already, but for the sake of people watching this later, or if you go back to it, digits are the individual numbers. The individual numbers that make up a numeric response, okay? So you could have a 2-digit number, you could have a 5-digit number. Here we have a 5-digit zip code, okay? Now, so all the preliminary stuff out of the way. All right, so now we know there are 10 digits. If you can repeat them, then each of these have 10 options.
Yeah.
Okay. So there's nothing hard about this so far, right? All right, so there's my 10 digits. Now, if I want to write, now here, and I will bring out this point too. In this section, okay, in this section, we're doing the number of ways to do something. We're doing the number of combinations, the number of options, whatever it is. These should all be whole numbers. These are not probabilities, okay? We're going to learn about the things that you referenced in your emails. We're going to learn about how to do that more with combinations and permutations in 4.5.
Yeah.
Okay, so we're going to combine all those rules from 4.3 and all these combination rules from 4.4 into 2, and we're going to make it into a whole section on probability in 4.5. So coming attractions. So if the digits can be repeated, then all we're going to have here is just 10 to the 5th power. Fundamental counting rule. 10 to the 5th. Okay. Now, what changes about this setup if you cannot repeat the digits? What do you think?
The first one would just become a 9.
Well, the first number could still be any of the digits, right?
Mm-hmm.
But then whatever digit I started with, I couldn't repeat that digit again,
Okay.
right? So the first digit, the first number, if I can't, this would be like 10, right?
Yeah.
But then my second number, I would only have 9 choices left.
Okay, yeah, because that one you already did 10.
Yeah, whatever number I took off this list, I wouldn't be able to choose it again, right?
Mm-hmm.
And similarly, I would have 8, and then 7, and then 6. Now, why did I stop?
Because you only have 5 digits.
Yeah, that's the other thing that students do. They go all the way down to 1 and they get a huge answer and they're like, I don't know why. But there's only 5 digits in the zip code. That's why.
Yeah.
So you have to be a little careful there. I'll let you work those out on your own, but those are.
Okay, and then I would multiply 10, 9, 8, 7, and 6.
Mhm.
And do I multiply by 5 or do I just leave them like that?
For the second part?
Yeah, for the second part, would I multiply a 5?
You just multiply, no, you just multiply this out the way it is. 10
Okay.
times 9 times 8 times 7 times 6.
Let me calculate.
And I will put up the answer key so we can compare. But I'm pretty confident now that we have the answer key fixed for this part. So we'll see.
Okay, I got 30,240.
Perfect. Mhm.
Okay,
What
and
did you get for part A?
for A, I got 100,000.
Good. That's good.
Okay, and let me, before I leave, let me make sure I did 2 right.
Mm-hmm.
So for number 2, would there be like 6 ways to arrange video games on a shelf?
6 for the first one, right?
Okay, 6 for the first
And
one,
then what?
5 for the second one,
And then,
4,
right.
then 3, and then
Mhm.
2, and then 1.
Yeah. So 6 factorial, right? And
So
what is
the first one would be 6 because since that's what we're starting with, right?
well, the other way to think about it is think about this. If you had 6 objects, right?
Mhm.
You've
Yeah.
probably rearranged something in your life, knickknacks, books, clothes in your closet. Think
Uh-huh.
of some bracelets on your arm, anything like that, right? Think
Yeah.
of 6 objects. So if I have, let me see if I can make this semi-concrete for you. Let me see if I can make these look sort of distinct over here, right? So I've got these 6 objects that you see on the board, right? Now, if I'm gonna arrange these objects in an order, right? In a linear order. Now there's a difference, a little bit of a difference if they're in a circle, which is why before you leave, if you have time, I want to do number 4 with you, because number 4 tends to get people. And number 4, there's not a mistake in the key as far as I know, but there is a mistake if you're using the textbook. There is a mistake in the textbook on the second part of the question. So I want to bring that up in case, because I know sometimes you refer to the textbook and you're not the only one, and you should, but there's an error there. So we have 6 objects, and I'm just going to make 6 slots here. Now, I could put any of these 6 in the first slot, couldn't I? So any of these 6 objects can go in the first slot.
Yeah.
So that's going to mean there are 6, right? Now, let's say I choose, let's use green. Okay. There we go. Let's say I choose this to be my first object, right? Now, I can't go back and choose this object again because it's already shelved. It's already there.
Yeah.
Right? So I'm going to choose one of the others that isn't there. So maybe next time I choose this one. So there's only 5, right? And then similarly, I continue that process. There's 4 options left, isn't there?
Yeah.
Aren't there? So there's going to be 4, and then 3, and then 2, and then 1. That's why that works.
Okay.
Like
So
that.
because you already, for the first one, you already arranged one object in there, so you can't arrange it like that again, so it'll go down.
Well, just think about pulling books off your shelf, right? If you've ever moved and had to put books or anything back, right?
Yeah.
You pick something to shelve first, don't you?
Yeah.
If I have 6 objects I have to shelve, then I have to pick one of those 6 objects. I can pick any of them. So I have 6 options for that first choice. After I've chosen it, it's already in the shelf, right? So I only have 5 left after that.
Yeah.
That's where it's coming from.
Okay.
Does that help a little more?
Yeah.
Right.
I'm gonna try number 3 and 4.
Yeah. 3 shouldn't be too bad. Number 4, the second part of it might get you. Well, you're working on that. I'm gonna come over here for a minute and we're gonna
Since number 3 says 5 numbers each, would I put 5 for all of them?
So let me check that. Let me remember what it says here. It says that I need to share my screen. Let me see. Let me see number 3. 5 numbers each, 0 through 9. So there's 5 options, but you're picking from 10 digits, right? So if it depends on if you're allowing it, right? So it says, although repeats are allowed, so normally in this game, we could repeat it, right?
Yeah.
How many numbers are possible if you can't repeat them? So how many options would you have? Think of 5 slots, okay? So kind of like the zip code problem that we did, right?
Yeah.
But now you can't repeat the digits and you're only doing 5 of them. So how many options are you going to have?
I only have 5 options.
There are 5 slots, but that's not the same as having 5 options, okay? You have to be a little bit careful. This is actually the same question as 1A. It's just a different scenario, okay? Because what happened let me see if I can clarify something, because that's the second time that it's come up for you, okay? When I'm talking about with the quinto problem here, right? I've got the digits 0 through 9. So we've beaten that into the ground. So we'll just bypass that and say refer to the previous part of this. Okay, so we've got this. Now, normally what it's saying is that we would be able to repeat these digits.
Yeah.
Okay. So if you can repeat them, then here's what I mean. When I say how many do I have? These are my options, right?
Yeah.
So there are 10 options here, right? When I refer to the choices, I'm referring to the individual numbers, the individual decisions that I'm going to be making. So if you want to make the table like you did before, you can say first, second, third, fourth, fifth, right? Now, if you can repeat them, so I'm gonna make this have, we're gonna do 2 versions of this. So we're gonna do the choices, and then we're gonna do the number of ways that I can do this, right? Well, on my first choice, I have 10 ways to do that, right? Now, assuming that I can repeat them, these would all be 10.
Yeah.
And I would get 100,000, right? Assuming that I can repeat them. If I cannot, so this is if repeats are allowed, right? But if they're not allowed, if I cannot repeat, if I cannot repeat, then what happens is that my number of ways changes a bit, right?
Mhm.
So I still have 10 for the first one.
Mhm.
But once I've chosen a number off of this list on the left, I only have 9 options left. I don't know which 9 options, but I only have 9 of them. So
Mhm.
then I have 8, 7, and 6. So it's similar, it's very similar to the zip code. It's just a different way of looking at it. This answer, if you can repeat them, is 100,000. And if you can't repeat them, I think it's like, what is it, 40,000 something
Mhm.
that we got? 90, and then, let's see. Does that ring a bell at all?
Yeah.
Do you still have questions about that?
No, I don't. I kind of get it. Number 4 is a tricky one. I was reading through it.
Yeah, that's why I wanted to go over it, because number 4 is always a discussion every semester. So how about the first part? The first part's not so hard.
Mhm. 8
When
dogs are selected, so uh we have a choice of from 8 dogs.
Yes, right. Mhm. We have 8 dogs and they're in a line, right?
Uh-huh.
So it's just like the shelf.
Yes.
It's just like the shelf. So that is not usually the problem. It's the circular arrangement that's a big deal. And that circular arrangement is the one that's tricky. And actually, I think, come to think of it, there is a mistake still. We fixed this, but we didn't fix it here, because I remember her getting a different number. Because I'll have to let her know that. In fact, while you're working on A, I'm gonna mute my mic for a minute. Okay, I'll be back. I'm still here. What I'll do is I will.
Do you want me to solve A?
Yeah, see if you can get the first one
8
with the
dogs are
dogs in a line.
How many ways can they line up to enter the room?
I'm gonna mute my mic, but I'll leave my camera on because I'm gonna let her know that there's a mistake.
Okay.
Sorry to keep you waiting, Giovanna.
It's okay. So
How did you do with the first one?
I finished the first part and the answer matches the answer key for letter A.
Woohoo! Okay, now can you impress me and do the second part? If you need help, it's okay. But if you already know, I'll be very impressed.
It says the judges randomly choose the dogs to parade around the ring in a circle. So they do have 8 dogs to choose from.
Uh-huh.
And the number of ways, I know it wouldn't be the same as the first one though.
Okay. Okay.
So would it be from 7 to 0? I mean 7 to 1 or?
Actually, that's really good. But can you tell me how you came up with that?
Because 8, we already have like 8 ways of arranging the dogs, and it says that the judge randomly chose the dogs, so
Okay.
there's no longer like 8 ways of randomly choosing the dogs.
That's actually not a half bad explanation. That's actually pretty close to, that's impressively close, actually. I think that's as close as I've seen a student get in a while. Well, no, because it's really hard to understand exactly what's going on here. So you did a really good job. Actually, we have a circle, right?
Uh-huh.
And you're right that we have 8 dogs on a circle. The thing about having a circle that makes it different from a line, okay,
Yeah.
is you have to choose, and you kind of said this, but you kind of didn't quite get there. You choose a focal point.
Yeah.
Okay, you have to choose. So we're going to put 8 points on this circle just so we could see what's going on. So I'm going to use the 4 cardinal directions here, and then I'm going to use the middle directions from there, and one here, and one here. I'm going to actually draw a line. Oh, not a circle. Oops. I don't want to create a circle there. I want to create a line. There's another one there and another one there. What's different about this is you choose a focal point. Okay. Now, it doesn't matter what focal point you choose. The idea behind it is that whatever this focal point is, wherever you're sitting, if you're sitting or you're standing anywhere on this circle, you're going to have the same point of view anywhere here. You're not going to be looking at the same 2 dogs, but you're going to have a dog on your left and a dog on your right, and then you're going to have the same spaces for the other dogs. So essentially you can think of it, and this is what you were getting at with the 7. You can think of it as, once you choose that focal point out of 8, because you've got to choose in effect where the circle starts, right? Once there's one place for that, not 8. Okay, there's one focal point for that, and after that, then you have to put the other dogs randomly in order after that. And that's where it's coming from. Now you're gonna find out that answer that's on the key is not correct, like I said, because it matches the one in the textbook. And that's why I wanted to check and make sure, because that's actually wrong.
Okay.
So I wanted to, and she's gonna fix it. That's why I was talking to her right now.
Okay.
It's actually going to be 7 factorial as your answer. So you did get the answer. Congratulations.
So
But
I would put 7 and an exclamation point, right? And 7
you
factors.
could do that, or you could also, if you wanted to do the choices, you could say that for that first dog, who's our focal point, like we have in effect, we have we can make any of the locations, but we have one focal point in the circle. That's
Okay.
the issue.
Okay, because we don't count that point because it would be like the same.
Yes.
Okay.
Yeah.
Like we wouldn't count it because it's already there.
Well, essentially what happens is, regardless of which focal point you choose,
Mm-hmm.
the number of dogs relative to you is the same
Okay.
at every focal point. The dogs aren't the same, but the way they're placed is the same, if that makes sense. So the focal point here, you have one focal point, and then once you choose that focal point, the other 7 dogs can be arranged around it however they are arranged.
Mm-hmm.
You see? Because in effect, what happens is once you choose your focal point, think of it like a pair of scissors. Once you choose whatever your focal point is, imagine clipping the circle there. And then your circle becomes a line, and you just have a line with that dog in the front.
Yeah, because we already started there.
So it's really 7 factorial, which is 5,040, which is what the answer should be.
Okay. I'm
Okay.
gonna try number 5 and 6 to see if I could do it.
Yeah, yeah. Keep going. You're doing a great job.
Just to be clear, number 5 would do permutation and combination, right?
Let me look at it real quick. Let me check, because I don't have it memorized yet. So let's see. You're looking at number 5?
Mm-hmm.
Number 5. No, you could, but number 5 is actually, I use the counting rule.
Okay, well, let me try.
I use the counting rule because there's different numbers there. Okay.
Okay, I'll try the counting rule.
How are you doing there?
I'm on number 6 right now.
Okay. Number 5 was okay.
Number 5 went good. I got the answer right.
Okay. How are you doing with 6?
I'm about to solve it to see if I get it right first.
Okay. Remember, there's 2 parts to the question, isn't there?
Uh-huh.
How are we doing with number 6?
I'm stuck on the letter B, the second part.
Letter B, okay. Did you get letter A?
Yeah, I got it.
Okay, so what's sticky about the second part of it?
I'm
How
saying
many?
how many, if I have to use all 4 numbers as the first 4 characters in the password.
So think of it as having, you still have a 7-character password,
Mhm.
right? So think of it as having 7 slots.
Mhm.
So we have 7 choices that we have to make, right?
Mhm.
And it's all about how many options we have for each one. So there's my 7 choices, right?
Yeah.
Now I know that I have to use a number as the first 4 characters. So this means that I have to have a number here. I have to have a number here. I have to have a number here. And I have to have a number here, right?
Yeah.
Now, the other characters can come from this list, right?
Mhm.
So now, how many numbers do I have?
I only have 4 numbers.
4 of them, right? So I have 4 options for the first number.
Yeah.
Right? And assuming that I cannot repeat them, I have 3 options for the second one, 2 options for the third one, and whatever the leftover number is for the last one, right?
Yeah.
Now, how many characters are left in my list? Go back to your list. How many?
8.
There are 8, right? So from those 8 characters that are left, so here I have from the 8 remaining characters, I choose, right? So again, I can't repeat. So now I have 8 choices for this one. I have 7 choices for this one. And I have 6 choices for this one. And I stop because I'm out of characters in my password. Okay, so you can write this as 4 factorial if you want, times 8 times 7 times 6, but you're going to multiply all of these together now. Okay. So we have 4 math probability, whoops, clear, 4 math probability factorial times 8 times 7 times 6. This is I'm getting 8,064 for this
Yeah,
answer.
I got the same thing.
So this answer would be 8,064. Okay. And I think you can handle number 7, right?
Yeah.
Be careful with the combination versus the permutation there, though. That will get you. And then most of the rest of these you can handle using the combination and the permutation.
Yeah.
Just keep in mind that you're not getting any probabilities in this section. Here we're just dealing with the number of ways to do something.
Okay.
Okay, so all of these answers should be whole numbers, because we're not doing any probabilities until we get to 4 or 5.
Okay.
Okay,
Okay.
how we feel? You feel better about the section now?
Yeah, I am.
Feel like
I'm
it's
gonna study it a bit to like try and understand more what the question's asking me because I'm starting to get it.
Mhm.
They're just
No,
some
this takes some practice. Remember, we're having I'm having extra tutoring sessions tomorrow and Thursday. Thursday, the tutoring I think runs from, I think I have sessions that start at 4,
Okay.
and then and then there's, I think yours, the one that's devoted to your class runs until 8 or so. And if
Okay.
there's people here, I'll stick around because after Thursday, we don't have tutoring until next week.
Okay.
So, okay.
Okay.
All right. Keep up the good work, my friend.
Okay. Thank you.
Thank you for helping us find our errors. We appreciate it. We're sorry to make you pull your hair out. We don't mean to do that, but
It's okay.
all right, take care. We'll talk soon.
Okay.
Bye.